as always, this is our SQL Office Hours sessions. I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team and part of the traditional, the offline Ask Tom Answer team. It's our job to help you get the best out of Oracle database and hopefully have a little bit of fun whilst doing so. So with that in mind, I've got some SQL magic lined up for you today. Something new, something hopefully you haven't seen before. Before that, we did have one question came in advance. It's a fairly simple one, so I'll just cover that off quickly and then we'll jump into a bit of a demo. So let me just share my screen again, and if I pick up the right one, there we go. Okay, so we had a question come in. Someone had some partitioned index, and they wanted to find the names of the tables these were on based on the partitions and the subpartitions. I was like, well, what's the issue here? Why are they asking? Well, if you look at the star ind partitions or subpartitions views, they just contain the index name. They don't actually have the table name on them. So if you just query those, you can only see the index. And they were saying, well, how do I get the table name based on these? Well, it's fairly straightforward. You have to join it to the user indexes table, which has the table name on it, on the index name, unsurprisingly, and then you can just pull the table name out. So pretty straightforward. It's just a matter of going back, working your way back up the object hierarchy effectively from the index to the table. Any questions or comments on that before we move on? Nope. Okay. So if you've got questions, put them in chat. I am keeping half an eye on it, so I can put them up later as we go along. So, as I said, I got something a bit different lined up for you today. So some SQL magic. And okay, let's just recap. So we got our table here, 2 columns, 5 rows in it. And as I said, you can do a basic pivot on it, and we can get the value and list out the row values we want to become columns like that. So we got our 1 row and our 5 columns. And let's just run back to the table. So as I said, this is a really handy, really powerful operation, and there's a lot of applications to it. But I don't want to use a pivot function to do that. That's just boring, right? What I want to do is run some DML, an update statement, and convert the table to its pivoted form. So here we go. I've just got an update, and I'm going to tell it to pivot the table. So we do that, and we'll commit it. And what do we find? There we go. It's converted all the rows to columns. Fantastic, right? So that was pivoting, converting rows to columns. You can also do the reverse, convert columns back to rows. And you do that with the unpivot operator. But again, I don't want to use unpivot. What I want to do is do some more DML, run another update and unpivot it. We'll do that, commit it, and we find that, bang, we're back to rows again. Awesome. So this is really cool. And as I said, pivot's a really common, powerful operation. One of the most common requests people have for pivoting is they want a dynamic pivot. So the columns to change dynamically based on the table of your input. Great thing about this update pivot, it is in fact dynamic. So just to prove that to you, we'll stick another row in there with a new value. So we've got 6 rows in the table now. So you can see row 6 is appearing there. If I pivot that again and commit, we will find we now have 6 columns in our output. There we go. So it is dynamically working based on the values in the table, or the rows in the table. And we can do the reverse as well. I want to chop some of these values off. I'm going to chop the last 2 columns off. And I don't want to do that with an alter table. Let's just go with a delete. Let's delete those last 2 columns off. Save that. And we find that, yep, we're back down to just 4 columns. Pretty cool. So what happens when we unpivot? Well, hopefully we'll just have 4 rows in the table again, right? So we'll do that, commit, and yep, there we go. We're back down to just 4 rows. So as we see, it's dynamically pivoting and unpivoting based on the number of columns or rows in the table, and it's all working on the fly. Fantastic. So that's pivot and unpivot. I want to do something, take it to the next level, do a transpose. So this is a kind of double pivot unpivot operation. So instead of a table with 2 columns and 4 rows, I want to take it so it has 2 rows and 4 columns. Well, actually 5, because I'll add a 5th to say which the source column was. So I want to transpose it, and I'll do an update to do this as well. We'll run the update and save, and hopefully we'll find, there we go. We've transposed it into columns. So that was the dynamic update pivot. Obviously, I've got some jiggery pokery going on here, some magic in the background. Does anyone want to take a guess as to what's actually going on here before I reveal how it's really done? No one brave enough to. Smoke and mirrors, lots of smoke and mirrors. It's not a table, but a view. Yep. Okay, so a lot of guesses coming in here. Yes. It's like there's a lot of sleight in hand going on, a lot of smoke and mirrors, but actually Dennis has got the actual answer at the back there. So it's a view on a polymorphic table function. So this is something new that we introduced in 18C. These kind of we've had pipeline table functions in the past, which allow you to dynamically generate rows in your output, but polymorphic table functions actually now allow you to manipulate your output, so change the columns that appear in your result sets. You knew because it was impossible in 11G. Okay, so let's just look at actually what's going on here. So we can see, if we look at what my magic pivot table is, as we said, it's just a view. And we take a look at the text of the view, bring that up. Oh, that's a bit tiny, unfortunately. But you can see what we're doing is selecting this. We're returning this query. So we do that. So magic columns is our polymorphic table function, and I'm passing the real table, magic table columns, into it. So what is that? Well, that's just the table we saw to start with. We've got the 2 columns and the 4 rows, or 5 as it was originally, and then we manipulated them as I was going along. So how is this actually working? What's really going on in the background? Well, as we say, we've got the view over the top of it, but there is a couple of invisible columns on this, is pivot and is transpose. And we can say by setting these to yes or no, the polymorphic table function is able to read those column values and then decide how to change the output appropriately. And of course, I've been very naughty. How have I actually done this? Well, there's instead of insert trigger on the view, which is intercepting the updates and then pushing those changes down to this base table and actually changing the row values. So that's kind of the brief high level what's going on. So accurate, it's not pure SQL magic. It's kind of SQL plus PL, SQL plus 18C magic. Yep, that's fair. I mean, all magic tricks, when you look at them, they're really explained to you, are never really magic, or a lot more mundane they first appear. But hopefully, this gives you some idea of how this works. So now, just trying to jump back to the slides and explain how this really works, or the engine behind it. So to use a polymorphic table function, you need the function itself, but you also need a package, which is the engine. That's the driver for the result set that you get. And there's a couple of things that we have in here. So first up, we got a describe function. And this is what tells the database which columns will or won't appear in the output of your result set. So you can pass your table in and you can add a whole bunch of new columns onto it, or you can look at the columns that are there and strip them out so they don't appear. Then, having told the database what the result set's going to look like, we have to assign values to any new columns we've generated. And we can do that with this fetch rows procedure. So this is where we set those values. After I pivoted the rows into the number of columns, I actually need to put the values in there. So how do we do that? So I'll kind of walk through very briefly how we do this. So we'll start off with the describe function. This is where I take those rows and convert them into columns. So how do we do that? So I'm have some variables, checking whether or not we've set it to pivot or transpose. And if it is, so we got our tab column count here. That is our input table. It's looking at all the columns there. And for each one of those, I'm setting the pass through to false. So if you set that to true, which is the default, then every column in your input appears in your output. Set that to false and it suppresses them, so they don't appear in the result set that you get. So if you want to strip some columns out, then you can get rid of them this way. Then we've also got this for read parameter. So we don't want it to appear, but I still actually need those values so I can pivot them into the new columns. We set that to true, so we can actually fetch those values and read them when we're processing the data set as we go along. So that's kind of the basic. If we are pivoting, we want to hide those existing columns. How do we add the new columns? Well, what we need to do is kind of set them all up, loop through the data, table data, and set those new values up. So we got a loop here. I'm reading through the table itself, getting all the column names, and they are just the values, row values in the table. And then I've got this new columns array. So this has got a column metadata type. It's a new type for polymorphic table functions. For each row, incrementing that and initializing those variables, and then stating what the column is called and its data type in this procedure here. So this is saying what it's called, and it's a varchar2 column. Fairly straightforward. So we've got that. We've initialized our array of columns. Next thing we need to, final thing we need to do here is actually return it, or tell the database what this is. So at the end of our describe, we're returning the describe function, which has these new columns. Notice also there's this interesting row replication factor. So as I said, those are generating columns. We've got this row replication parameter. So what's that about? Well, I had 5 rows in my input on my table to start with. I want to convert those to just 1 row. So what I need to do is stop the 4 after the, all except the first appearing in the output. The row replication parameter allows you to manipulate whether or not columns appear. So you can do 3 things. You can just pass the row through as is. I'm saying column when I should say row there. Sorry about that. So we can pass the row through as is. We can hide it completely, or we can duplicate it n times, as many times as we want. So here we need to hide the extra pivoted values. So we're going to set that to true so we can do this. So that's our describe function. Next thing we need to do is actually assign the values to those new columns. So how do we do that? Well, first thing we'll do is get our environment. So here we're getting the row set. That is the source data, so we can read the input stream basically from the table. And then we want to know how many rows there are in the result set, so we can use that to loop through. So we do that, and then for each row in the result set, we're going to go through and see whether or not, see what values we're going to put into columns. And if it's a pivot, I need to assign the corresponding row value to that column. So for the ith column, if we've got n columns and we go 1, 2, 3, 4, 5, no, 5 rows, sorry, 5 rows in the input table, 5 rows, get the second row, we want that to go in the second column. We want the third row to go in the third column, and so on. So we need to loop through these, and if it's a pivot. So we're saying if it's a pivot, we need to flip those around. Now, this is something which drove me crazy for a little while and got me completely confused. Our row set here is indexed by the columns. So we've got an array of the columns, and then within, for each of those columns, they then have an array of the row values. So we're saying row set I is the ith column in our input. We then need to assign to that the value from the ith row. So we're doing second row to second column, third row to third column, and so on. So we're flipping those around essentially. So that's what that's doing here. We're taking row values, assigning them to the column values. Notice I'm taking it from the second column because we had 2 columns in our source table with names and the values. So I want to get the values, not the names. Next thing, we've got this rather interesting thing, this rep fac. That means the replication factor. So for each row, we need to say whether or not we're going to duplicate it, or how many times we want it to appear in the result set. So If we do nothing, we have a replication factor of 1 for all the rows. Everything after the first row in my input, I want to hide. I want that to disappear from the output. So we set that, the replication factor, to 0. So it just disappears and we no longer get it in our results. So we're hiding everything there. And finally, we need to actually pass that row replication to the database. So we call the row replication function and put the row set on the output stream with the manipulate changes we made to it. So that was a very brief overview of polymorphic table functions and how they, and specifically how this little trick worked that I just showed you. Any questions or comments, or what questions or comments do you have? Can I share the full code on LiveSQL? So there will be, I still need to do some tidying up on all this and sorting it all out. I will be writing all this up and sorting out eventually. So stay tuned for future stuff. I've got Open World coming up. Well, I'm heading off to Open World next week, so don't expect it in the next couple of weeks. I've got lots to prepare for that, but we will be coming. Things will be coming in the future. So Dennis, does an example JSON table work in a similar way? You mean the actual underlying implementation of JSON table? I don't know, to be honest, how that works. I mean, from a high level, from a high level conceptual point of view, it probably does, but from a actual detailed implementation, I've really no idea. Okay, so what do we see in the explain plan for a SQL query, which is based on such a view of a PTF? Good question. So let's actually jump back over. Let's reset the thing, and how well using such a view integrates into a big SQL query, which fetches data from several other tables as well. Any ways to optimize such a query? So good question about performance and how this works. So let's actually look at the function itself. So at the moment, I've just got the table as it appears. So if I'll just run an auto trace on that and we'll get some information. Come on, let's just, come on, SQL developer, play nice. Oh, it gets a bit funny sometimes about showing you what's actually going on. Let's just do it with explain plan. Explain plan, it'll show you what's going on for here. So things to notice. So we've got, if I zoom in a little bit, we've got the polymorphic table function step that will appear in your execution plan. So that tells you that you're getting the rows out of that. And we are passing into that. Let me just hide that. So passing into that the table itself, magic table columns. Now notice the cardinality. So it's using the base table for its cardinality estimates. We're saying magic table columns is a source, so it can look at the statistics on that table you're passing as an input to that. So if you compare this to like pipeline table functions and similar, where we didn't really know what was going on, so we kind of guess and end up with crazy numbers, which can lead to all sorts of weird plans. Here it is actually using underlying statistics from the base table. So that's not going to say it's perfect, but it's a step in the right direction. You're not going to have wildly misleading estimates. Well, assuming your stats are reasonably up to date. I don't have much else to say on that at the moment, unless you've got specific questions that you want to ask, Dennis. So theoretically, is it even possible to use hints with such queries? Well, I mean, you can always use a hint with a query, but how it works and whether the database uses it is obviously depends on your query itself. I guess you're talking about like trying to use an index hint or similar for the table that you're passing to the function. You mean their work? To be honest, I don't know. I'd have to look into exactly how the hinting mechanism works with this. Okay, so this is completely procedural code, so I don't think that the optimizer has too much to do with it, except maybe knowing something about the cardinality of the result set? Well, the thing is, as I showed, we can completely manipulate the result set to be something utterly different. We could squash a 100 million row table down to just one row in the output. I can't. Well, I guess if you're trying to do a dynamic pivot like this, that's probably an extreme example. So it's not always the case. A lot of the time, you will be having your table and passing it back out pretty much as is without changing too many of the rows, but potentially you can. So that doesn't mean that it's completely, the optimizer going to get it completely bang on. Thanks ODC, by the way, that we have office hours this year. Well, so you're finding these office hours useful then, Dennis? Yes, cool. Yes, today is, those of you who follow Twitter have probably seen that it's Tim Hall set up the ODC Oracle Developer Community Appreciation Day. So there's a lot of tweeting and posting going on about that. So check that out. If you don't follow Twitter, then you might want to go over and see check that out, see what's going on. Yeah, otherwise I wouldn't attend almost all of them. You can't be attending all of them, Dennis. There's an awful lot of these sessions. But yes, it's good to see you coming along. Okay, so do we have any other questions on polymorphic table functions or any other general SQL questions people have? Do I know if there's any plans for supporting of PTS in Apex? I know that they are looking at these and seeing how they can integrate them. If you're going to use a polymorphic table function and it's got a static output as static column list, as in you're not actually manipulating the columns, then you can use that. But in this instance, or if you're using them what they're designed to do, which is basically change your column output, then they won't work currently. They are looking at it. I don't know where they're going with that or how that's going to be integrated, but certainly an interesting feature and possibly opens up some options for them in terms of how they do their processing. Yeah, exactly. In that case, they're not truly a PTF. You're right. If you're just passing the same columns out as you passed in, then it's like, well, why are you doing it? We strongly need examples such as this one with full explanations to digest. So please, after the open world, do share the code. So I will say there is actually a lot of examples of this are polymorphic table functions on already available in Live SQL. So I'll bring that up and just show you. It is, not the most straightforward of features to get to grips with. It did take me quite a while to figure out how to get this going. There are some things which are not immediately obvious. As I said, when we're processing the row set, it's an index of columns and then the rows. I would have assumed it's the other way around, but that's where we go with that. So yeah, it takes a little while to get your head around, but it's certainly very powerful. And if Live SQL would actually come up for me, I can show you we've got several examples already in here. And so one example that's already in Live SQL, I believe there is a dynamic. So this is one I built, a CSV to columns converter, but there is already a dynamic unpivot. I think we called it the stack, which is slightly misleading or confusing, but this is a dynamic unpivot PTF. So you can see here, it's taken the standard employees HR table and pulled the manager and the salary columns out so that into rows. So there's lots of these examples in the docs as well. We need examples with table semantics. Most use row semantics. What is it specifically that you want to see on table versus row semantics, Edith? What is the thing that you want to know there? But they say there is a whole stack of these polymorphic table functions in there. There's great place to get started. They start off with even the most basic things, like the no-op, NECO, which just adds some columns. In terms of kind of, okay, Dennis, actually I'd say the most common case which I have in my head for a PTF is to show a transponded report where you have the two columns which are keys and the rest are some values. And then you need to put the values of the column as rows and values of the second columns of the report as the cell data. And there's some aggregation. So quite sort of the example I just showed you then, Dennis, where I did the transpose at the end. Is that what you mean there? Switching the rows and columns over and summing them or aggregating them in one way or another? Yes. Well, you wrote, there's some magic. Yeah. Yes. So in terms of, like on the SQL, it's the SQL standard, polymorphic table functions are now part of that. And one of the use cases they do put out there is that is dynamic pivot. And as I showed, it is possible. I'm working on a more general solution. Stay tuned for that. I'm hoping to get like a general or slightly more general transpose or pivot function. It's a bit more complicated than when you know you're just fudging the values and you can do a lot of smoke and mirrors in the background. But that was one of the use cases that was highlighted in the SQL standard. Another interesting one is something they called top N plus. So let's imagine we got our employees table, and you want to show for each department the top 3 employees by salary, so the 3 highest earners, and then you want to show a line below that. If there's more than 3, you just want a single line which says how many employees there are and their total salary, or something like that. So you get the top 3 and then a 4th line if there's more than 3, giving some summary information. So they call that top N plus. That's another, I don't have an example of that with our current implementation. Hopefully we'll be able to get there soon. But that was another example of something they used. One of the things examples they use, or people have asked me about, is actually hiding columns from the output. Certainly the UT PL/SQL team, so have taken on Stephen's PL/SQL unit testing framework and really enhanced it. They want to use it so they can do things like hide specific columns from the output, which aren't relevant to the test. So that can be quite useful there. Maybe you want to exclude auditing columns from your results, or just strip out all columns of a particular type. It allows you to do things like that. Okay. Any other questions or comments on this? Does this, what do people think about this feature? Crazy, weird madness? Looks like something you want to play with, or just so wacky you don't see a point to it? What do people think about this? It's something I long for, Dennis. Yeah, okay. And they're long for 18C XE. Stay tuned. It's coming soon. Yep, 18C's XE. For those of you who aren't familiar with 18C XE, so you probably all know of XE Express Edition, which is our free version of Oracle Database. XE for 18C is coming soon, and it's got the usual kind of hardware limitations: 2 CPUs, 2 gigs of RAM, 12 gigs of disk. But the really interesting part of it is Enterprise Edition with pretty much all the options and packs. So in memory, advanced compression, advanced security, they're all included in XE for free. So you can then download this and use it for whatever you want, basically. Fantastic, right? So you might be going, well, hang on, it's completely free. Okay, we've got some hardware limitations. What's the catch? Well, there's going to be no patches for it. So if any issues with it, you're kind of on your own. You have to wait till the next year's release. Which brings the next good news is every full release of an Oracle Database will have a corresponding XE. So we've got 18C this year, We'll have 19C XE next year, and so on. So, yes, you won't get security patches, but functionality wise, you can keep up to date much more easily with that. Pete, yes, I've no doubt there are use cases for PTF, so I just hope I can recognize them when I see them. Yes, I think part of this is just knowing it's available, seeing what you can do with it. We need the technique of the PTF to sit in our fingers, like table functions, to be able to feel what they can use for. Yeah, he's with Pete. Yeah, I think this is one of these things that as more people get their hands on 18C, sorry, probably will happen when XE's out. People come up with more interesting and creative uses for it. So, it's one of the big banner changes for SQL in this release and SQL generally. So I'm sure people will come up with all sorts of stuff. The dbms TF package contains many procedures and is not very clear on exactly what they do and when we should use them. That is a very good point, Judith. And all I can say is I agree with you. And I think as we flesh out more examples and people understand this more, get to grips with it, we will hopefully things will become clearer. I use pipeline table functions a lot and refer to them as PTF, which doesn't help. Yeah, I think we've doubled up on terminology a bit there, haven't we? So it's going to be a bit confusing. Nope. Okay then. Well, as always, I really hope you enjoyed this, but more importantly, I hope you learned something. I think, PTF, polymorphic table functions, are a big feature. There's going to be a lot of power for them. It'll be interesting to see what use cases people come up with. So I just want to thank you all for joining me, and go about the rest of the day. And I'll hope to see you again next time. Okay? All right. Thank you all.